Okay, so I have my guided notes pulled up, which is what I would normally print out for you guys. Obviously, I'm not there to be able to do that for those of you who are in the classroom. So you guys all are going to have to write all of the words. I know it's terrible, but you can do it. I'll make sure and give you guys time. And if I start moving too fast, please unmute and just tell me, and I will slow down. Okay, so we've been talking about solving a system of equations, and we've looked at a few different ways to do that already. And now we're just going to look at another way, which is to use matrices. Hopefully you've at least seen a matrix before. If not, I will explain it. Okay, so a matrix is an ordered array of numbers. That's the first thing that you need to write in your notes. Okay, here's an example of a matrix. A matrix could have anywhere from just one number up to an infinite amount of numbers in it. This is just an example of a matrix that has 3 rows and 3 columns, and I just made up random numbers to go in it. The numbers inside a matrix are called elements. So the numbers are called elements of the matrix, and matrices are named according to the number of rows and columns they contain. So the number of rows followed by the number of columns gives the dimensions of the matrix. I'm going to give you guys some time to write that. Okay, so dimensions of a matrix. If we look at this matrix that we drew up here, I said it has 3 rows and 3 columns. So this is a 3 by 3 matrix. So the number of rows always comes first, then the number of columns. Okay, let's move down to this next paragraph and I'll give you guys some time. It says, and it's an augmented matrix, AUGMENTED, augmented matrix. It has a vertical bar that separates the columns of the matrix into 2 groups. And then we'll look at the example here in a second. Go ahead and write that down. The next sentence that says, for example, write all of that, and then we'll look at it together. Okay, so we're given this system of equations, x minus 3y equals 1, and 2x plus y equals -5. So if we were given this system and we wanted to solve it using matrices, we would start with this augmented matrix. We're going to have 2 rows because we have 2 equations, and we're going to use the coefficients from our variables. So the first equation is just 1x, so we're going to use 1, minus 3y, so we're going to use -3. Then we're going to draw that vertical bar that an augmented matrix has before we write our answer, which is 1 for that first equation. The second equation, 2x, so we use 2 plus y, so that's just 1y, we're going to use 1, equals -5. So -5 goes on the other side of the bar. Then we close our matrix. Okay, I want to make sure that you guys all have this before I move on, because I'm not sure exactly how. My document camera that I normally use for you guys to take notes from is not working, so I'm trying to do something different and I'm not sure exactly how to do it. So I'm going to give you guys a couple more minutes on this page. Make sure you have everything down. Okay, hopefully you were able to get all of that. If not, I'm recording this so that I can post it later and you can always go back and pick up any parts that you missed. So right now, go ahead and copy down these matrix row operations. Numbers 1, 2, and 3, copy those down, and then we'll look at the examples together. Okay, I'm back. Sorry. Hopefully that was plenty of time for you guys to copy down those matrix row operations. So let's talk through them. Number 1, it says any 2 rows of the matrix can be interchanged. So the matrix that we just drew from those 2 equations, we could have written the first equation in the second row and the second equation in the first row. It doesn't matter which order you put the rows in. Okay, number 2 says the elements of any row may be multiplied by a non-zero real number. So we can take any row of the matrix and we can multiply everything in that row by a number as long as it's not 0. So the same way that we would multiply one equation by something in order to get one of the variables to eliminate when we were solving systems by elimination, It's the same thing here. We're just multiplying a row of the matrix by something to get it to look how we need it to look. Okay, number 3, any row may be changed by adding to the elements of the row of the product, or sorry, this is worded weird. Any row may be changed by adding to the elements of the row the product of a real number and the corresponding elements of another row. Okay, that's very wordy. All that means is you can multiply one of the rows by something, and then whatever you get, add it to another row. And we'll look at an example of that too, and hopefully that'll become more clear. So let's look at example 1. Use row operations to solve the system. Okay, well, first of all, we have to draw our matrix from these 2 equations. So we have 2 equations. There's going to be 2 rows. We have x, the coefficient is 1, minus 3, so the coefficient is -3. We're going to draw our bar, which kind of stands for our equal sign here, and then 1 is on the other side of the equal sign. 2x plus y equals -5, so we've got 2x, 1y equals -5. Here's our matrix. Okay, so what we want this matrix to look like, our end goal is this, and this will be our end goal for any of these examples. We want the first row to have a 1 and a 0, and then any number here. I'm just going to put A. It can be any number. We don't care. The second row, we want it to have 0, 1, and then any number here. It doesn't matter. So we want to change this matrix that we've written for number 1, and we want it to look like this. We want 1s and 0s, and then we don't care what these numbers are. That's why I just put A and B. So we're going to use these row operations to change this matrix so that it looks like this one. Okay, so right now our matrix has 1s where they're supposed to have 1s, but this -3 needs to be a 0, and this 2 needs to be a 0. So we work row by row. In the first row, we have a 1 where we're supposed to. We need to change this -3 so that it becomes a 0. So the way that we're going to do that is by using this third row operation that we said was a little bit confusing. But the second row, if we were to take row 2 and multiply it by 3, 3 times row 2. What that would do is change this +1 to a +3, because 3 times 1 is 3. And then when we add that to the first row, that's going to change this -3 to a 0. So we're going to multiply row 2 by 3, and then we're going to add it to row 1. Okay, here's what that is going to look like. This first term, it's not going to be 1 anymore. It's going to be 3 times row 2, and the number, the element that's in row 2 in the first spot is 2. So 3 times the number in row 2, which is 2, plus the number in row 1, which is 1. Okay, the next one, we have 3 times row 2, and the number in row 2 is 1, plus the number in row 1 right here is -3. The last one, 3 times the number in row 2, which is -5, plus 1. Okay, so in the first row, we used row 2 to help us do what we needed to do in row 1, but we're not actually changing row 2 at all. We just used those numbers to help us with row 1. So the numbers in row 2 are not changing. 2, 1, -5. Okay, so let's do this math that we wrote in the first row. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3, plus -3 is 0. 3 times -5 is -15, plus 1 is -14. Our second row didn't change. 2, 1, -5. Okay, so we got a 0 where we wanted a 0. But what happened was, in doing that, we changed the 1 where we needed the 1. It became a 7 now. So before we move on to the second row, we need to change this 7 so that it becomes a 1. So we can do that by using the second row operation, which says we can multiply any row by any number as long as it's not 0. So to make 7 become 1, we can multiply by 1/7. So we're going to take 1/7 and multiply it by the first row. 1/7 times row 1. Okay, here's what that does. 7 times 1/7 is 1, which is what we wanted. 0 times 1/7 is still 0. -14 times 1/7 is the same thing as -14 divided by 7, which would be -2. And right now, the second row is not changing. 2, 1, -5. Okay, now we have the first row looking like we wanted the first row to look like. We have a 1, a 0, and then any number here. It doesn't matter that it's -2. Now we can start working on the second row. So the second row has a 2 where we need to have a 0. So when we need to change a number to a 0, that means we're going to use another row to help us do it the same way we did in this first step. So we're going to use the first row to help us change this 2 to a 0. So we're going to multiply the first row by -2. -2 times row 1, because that would give us a -2 in this spot. That would then add to this +2 to become 0. So -2 times row 1 plus row 2. Okay, so let's do that math. The first row is not changing. We're only using the first row to help us change something in the second row. So the first row is still going to be 1, 0, -2. Okay, the second row is -2 times row 1, which would be 1, plus row 2, which is 2. In the next spot, we have -2 times row 1, which is 0, plus row 2, which is 1. And the last spot, -2 times row 1, which is -2, plus row 2, which is -5. Okay, our next step is just actually doing that math. -2 times 1 is -2, plus 2 is 0, which is what we did all that for in the first place. -2 times 0 is still 0, plus 1 is 1. -2 times -2 is +4, plus -5 is -1. Okay, now we have our matrix looking the way that we needed it to look. We have ones and zeros in the right spot, and then the numbers out on the other side don't matter. So we're done using the row operations. Now what we're going to do is change these rows back into equations. So remember, the first number in the row is your x coefficient. The second number in the row is your y coefficient. The bar stands for the equal sign, and then our other numbers. So the first row becomes 1x, which when we have 1x, we can just write x, plus 0y, so we don't have a y term anymore, equals -2. The second row, we have 0x, so we don't have an x term for the second equation. We have 1y, so just y, equals -1. So now we have the values of our variables for our systems of, or for our system of equations. So our solution as an ordered pair is -2, -1.